Hello everyone, my name is Julian. I am one of the lab technicians at the Temmerman and Bates lab, and I will be taking you through the annual lab safety presentation today. First of all, we will have a short introduction about labs. Then we'll talk about HSE, which stands for Health, Safety and Environment. And in the end, we'll talk about some basic equipment you will be using on a daily basis in the lab. So first, for a short introduction. We will go through general information about people working in the lab, the lab space itself, and of course, general matters regarding the safety in the lab. The space itself is shared between 5 labs, being the Van den Broek lab, the Schoofs lab, Temmerman lab, Bates lab, and the Luijten lab. So these are our 5 PIs. Here we also have an overview of the ATP, which is a Dutch acronym, but translated, it stands for the General and Technical Personnel. So first of all, we have a list of our lab technicians. These are all the people who you will be seeing daily in the lab. If you will have any questions regarding any lab work, these are the first people you can go to. Then we also have technical support, being Arnold and Evelien, and our admin team and or financial network, being Kirsten and Marleen. Our HSE network, or Health, Safety and Environment network, is split up into 4 parts, being biosafety, chemical safety, first aid, and a first intervention team. These lists are not exhaustive. More of our ATP, so more of our lab technicians, for example, will join these lists as they finish their trainings in the coming weeks and or months. But in general, should you have any questions regarding biosafety, which is the handling of live organisms, cell work, or their waste disposal, you can go to people who are trained in biosafety. Same regarding chemical safety. So should you have any questions regarding certain chemicals, their handling, again, waste disposal, please go to people who are trained in chemical safety. Then we also have a list of people who are formally trained in first aid. So should someone need immediate medical attention, in the first place, get one of these people. And in case of a larger emergency, for example, if a fire breaks out and we all need to evacuate, people who are part of the first intervention team will have yellow jackets and they will guide us all to safety. Here you can see a plan of the ground floor of the lab. There are 4 labs with designated personal bench space. These labs are designated with a green name here on the map. So of course, all the rooms have a room number, but for convenience's sake, we also gave the rooms a name. We have Terra Firma, we have the DNA lab, which is also called the Continent. We have the Island and Terra Nova. It is your own responsibility to keep your own bench space clean and safe, but it is also especially true for the common lab spaces. So if you look on a map, for example, the room number 66 is the proteomics room, which is a shared lab space. As multiple people use this lab during the day, it tends to get messier a bit quicker. Even more reason to do your best and keep your work as clean as possible, both for your own safety, as for the safety for everyone else in the lab. Then on a map you can also see 3 doors. These doors need to be closed at all times. Of course, we have 2 entry doors, which need to be closed for obvious reasons. We don't want any random people walking to the lab. Then there is also the centrifuge room, which is room number 50. This room tends to get quite noisy, and there is also a speed vac, a machine with a small exhaust pipe that leads to a ventilation system. as not to get any of the gases or the exhausts into the general corridor. We are also required to keep this door closed at all times. For some of the labs, for some of the shared lab spaces, additional training is required. So for example, we do have an L2 lab space. Before you can enter this lab and work here, you need to be trained by somebody of the ATP, and you will need to read the protocol number 30. In the basement, we also have a GelRed room. You will need to be trained by your supervisor and watch our online video modules, which you can find on YouTube on the following link. The proteomics room that I was talking about on the previous slide is a bit of an exception, so you will need to be trained by your supervisor or by myself. This is extra important as we do a lot of sample preparation for mass spectrometry in this room, which is very prone to contaminations. These contaminations can come from keratin, which you can find on your skin and hair, as well as autoclaved plastics. So whenever you are working in this room, you are at all time required to wear gloves whenever you're touching anything except the computers. And it is forbidden to enter the room with autoclaved plastics, as these plastics tend to release polymers that also contaminate our mass spectrometry samples. Every door that leads to a lab also has a safety data sheet on it. This sheet clearly marks which hazards can be expected and what the access criteria are in order to safely enter the area and work in the area. These safety data sheets also show the name of the person in charge of the room. So in case anything happens in a room, anything breaks, or you have any questions regarding anything in the room, be it machinery or whatever, or the safety of the room, the person on the safety data sheet is the first person you should contact. Every lab also has a fire blanket next to it or in it. So in case of a small fire, these can be extinguished by pulling on the two blue ropes underneath the box, which releases the fire blanket. This fire blanket then can be used to carefully cover the flame, depriving it of oxygen and thus extinguishing it. In the main hallway, next to the DNA lab, there's also a small plastic eye shower. In case anyone gets any chemicals into their eyes, this eye shower can be used to rinse the eye. There are old eye showers that are connected to the main water system or water supply in the building. Please be careful not to use these ones, as it is quite an old building and most of the pipes are old as well and contain quite a lot of dirt. Washing your eyes with this water can make the situation worse. In case you need to call an emergency number, so for example, if a fire breaks out or there are incidents that require emergency intervention, please be mindful to never ever call external emergency numbers. So for example, 100, 101 or 112. Instead, the KU Leuven has its own internal emergency number and its own internal system for reacting to emergencies. So should anything like this happen and you are calling from a phone that is directly connected to the building's phone line, you can just dial 2222 and you will be connected to the emergency line. If you are calling from a cell phone, you will need to dial the entire number, being plus 32 16 32 22 22. The next part of the presentation will be about personal protection equipment, or PPE for short. The first priority in the lab is of course safety. For this, you are at all times required to wear a lab coat while working in the lab. The lab coat has to be correctly sized and at all times buttoned up. Another important point is to never roll up your sleeves, especially in the GelRed room. Contamination that would get onto your sleeves will be touching your skin once the sleeves would be rolled down. You are required to wear a lab coat at all times when working any of the lab spaces, but be careful to never ever wear them outside of these labs. So for example, the offices or the coffee room. Furthermore, we also have different kinds of lab coats. So apart from your regular white lab coat, which you'll be using usually during the day, we have 3 different kinds with a colored color, which can be yellow, green, or red. Respectively, the yellow is used for in locust rooms or whenever working with insects to avoid spreading any allergens. The green colored lab coats are used whenever you're working in a cell culture room to avoid bringing any bacteria or any other contaminants in. In the basement of the lab, we also have a gel red room where we run electrophoresis on gels and also image them. As gel red can be quite dangerous, a separate lab coat here is used to contain the contamination. Be careful to never ever take your colored lab coat outside of the designated area, as well as don't bring your own regular white lab coat into these areas. Also be careful to avoid contamination from the different lab coats onto your own by hanging them on top of each other. So here on the bottom you have a few examples of what to do and what not to do. On the left, you can see a person working in the gel red room without any gloves and without a red lab coat. The second picture from the left is taken inside of the coffee room or a room where you can get a lunch as well. In this case, it is forbidden to enter this room with a lab coat. The same is true for the next picture, where a person is sitting in an office space with her lab coat. On the fourth picture, you have 2 lab coats, but different lab coats, hanging next to each other, which, as I said, can cause contamination. And on the right, on the last picture, though it may not be as clear, you have one person working with a green color lab coat, which is used for cell culture work. The person next to him has a regular white lab coat, which is not allowed when working in the cell culture room. Regarding gloves, so these you will be wearing most of the time in the lab, though it is important to be mindful of the fact that you primarily use them to protect your samples from yourself. So in case you want to avoid contamination, or the other way around whenever you want to protect yourself from whatever you're handling. It is important to note that we do not use gloves at a microscope, neither a PC. So mice and keyboards also use them without gloves. There is one important exception, that is the gel red room. As I said before, gel red is quite a dangerous chemical, and you want to avoid contact with the skin at all times. So there is a PC in the gel red room that is used for imaging. In this case, you are required to wear gloves as well. Then also be careful not to touch any door handles, light switches, headphones, your cell phones either, with gloves, as these can be contaminated with chemicals and we want to avoid cross-contamination. Same as with the lab coats, it is forbidden to come into the coffee room and or offices in a lab coat and or gloves. Apart from gloves and a lab coat, there is also additional personal protection equipment available, which can be used whenever the situation demands this. So for example, in the middle, you can see a picture of a UV mask. Whenever you're working in a gel red room, for example, and doing gel extractions, you're doing this by quite strong UV light, which can be harmful to your eyes. So a UV mask would be important in this case. Same can be said when using a sonicator. The sound of a sonicator can be harmful to your hearing, in which case headphones are required. Um, Regarding also the sonicator, but more broadly as well, whenever you are working with dangerous solvents, please be mindful to do this inside of a fume hood. On the left, you can see a person working with liquid nitrogen. Here it is also important to say that before you are allowed to work with liquid nitrogen, training by ATP is required. Whenever you are handling very cold things, especially liquid nitrogen, it is important to protect your skin, your hands, by wearing cryogenic gloves. And with liquid nitrogen as well, you can protect your face and your eyes by wearing a face mask and or goggles. Be very careful because we have different kinds of gloves in the lab. We have cryogenic gloves, which protect your skin from very cold temperatures, but we also have gloves specifically made to handle very hot things. So be careful whatever you take whenever you need extra gloves. Here we have two pictures with a few examples of bad practices in the lab, things you should not be doing. So let's have a quick look at both of them. Maybe you can note down whatever you think is wrong yourself, and we'll have a closer look at them on the next slide. Regarding the left picture, there were a few things wrong. First of all, the person is not wearing her lab coat. Second, she has quite long hair, which should have been tied up. She's wearing sandals instead of closed footwear. Yes, this is required. Even if it is really warm outside, you are always required to wear closed footwear. And lastly, she is wearing gloves, which is usually required in a lab, but in this case, she's working with an open Bunsen flame, so a burning Bunsen flame, and she's working at a microscope. In both situations, you would not be wearing gloves. Regarding the Bunsen flame, there is also an exception. So whenever you're working under a laminar flow hood, you are required to wear gloves, even if there is a Bunsen flame burning. On the right, we see how it should have been done correctly. So her hair is neatly tied up. The person on the right is clearly working without gloves at a microscope. He is wearing his lab coat and also closed footwear. On a general note, be careful to only open the gas whenever the flame is burning, whenever you're using it, and turn off the gas after use. Now we're going to go through some general equipment which you will be using in the lab on a daily basis. These include pipettes, centrifuges, the autoclave, and balances. All are pipettes. I hope most of you already used pipettes in the past, but in any case, it is good to refresh our knowledge. Should you want to have a more thorough explanation of their inner workings, you can always go to the link which you can find underneath the title of the slide. The first important point when using pipettes is to choose the correct pipette for the volume you want to measure. A pipette's performance is best between 35% and 100% of their nominal volume. When taking up volumes under 35%, your risk of error increases. Second, use the correct tip for each pipette. So even though different tips may fit on the same pipette, their performance is best with the correct tip attached. And then a third point, that is how to set the volume. So please be very careful, as some of our pipettes in the lab have a lock. This lock is used to, well, lock the volume you're measuring, as not to change it by accident by turning the knob. So yeah, check that the lock is off. Then, depending on the volume you want to set, slightly turn past the desired volume. So for example, whenever you want to measure 700 microliters on a P1000, you would turn the knob a bit past 700 and then back to 700 to set it at 700. This is not the case with the max volume, so never ever turn past the max volume. This voids the calibration of the pipette. As I said, after turning it a bit past the desired volume, you turn it back, put the lock back on if there's a lock present on your pipette, and you are ready to use it. Number 4, also very important, is to maintain a consistent pipetting angle. When your pipette exceeds an angle of 20 degrees, you risk increasing the errors on your pipetting. Furthermore, whenever you put your pipette tip too deep into your liquid, into the liquid you're pipetting, you risk some liquid sticking to the outside of your pipetting tip, thus risking to increase the final volume. If you do have some liquid sticking to the outside, you can gently touch your initial volume to remove the droplets from the outside of your pipetting tip. At the bottom of the slide, you see a diagram of how to pipette. The ready position is the position how you normally find your pipette when you're not using it. After setting your volume you want to pipette, you can press down to the first stop. Then put your pipetting tip into the liquid you want to pipette and gently, slowly release the button. Then putting your pipette into the Eppendorf or whatever other container you want to pipette in, you first gently press down to the first stop and then to the second stop to release all the liquid from your pipette. And then again, let go to the ready position. Another thing to keep in mind is to keep your Eppendorf tube from the sides whenever you're handling and pipetting any temperature-sensitive reagents. This will prevent the reagents, for example your enzymes, warming up. So here we have a few examples of how not to handle a pipette. On the leftmost pictures, you see first of all the person holding the Eppendorf tube from the bottom, which in this case would be heating up his reagents, and the pipette is held at too big of an angle, increasing the risk of pipetting errors. On the right, we see how it's supposed to be done, with the pipette as vertical as possible, so having a small pipetting angle, and the Eppendorf tube is being held from the top. Here again, this diagram shows the drop in accuracy when you either one, submerge your pipette too deep into the liquid you're pipetting, or two, whenever you are holding your pipette at a steeper angle. Also be mindful not to take in any air whenever you are pipetting. So after you're taking up the volume you want to take up, just double check your pipetting tip that there are no air bubbles inside. Here we have a few things to keep in mind whenever we are not using our pipette and storing it. The first point is to use a pipette stand and store our pipettes vertically. Whenever we just leave them on our bench in a horizontal position, the inner workings of the pipette can get misaligned, which would void your calibration. Second point is to always remove the tips. Any liquid which remains in the tip will evaporate in time and get into the pipette itself. And again, this can cause troubles for the inner workings of the pipette. The third point is to always set the pipette to the maximum volume when we are storing it. Inside of the pipette there is a spring, and we don't want it to be stressed all the time. So set your pipette to the maximum volume to release any stress on a spring, thus increasing your pipette's lifespan. Then it's also important to know that there are two different types of pipette tips. One is completely hollow, and the second version has a soft filter in it. Be mindful that the ones that have a filter in it are more expensive, so we only use them when we really need to. And so when do we need to use them? There are a few occasions. First of which being when you want to protect the sample and chemicals from contamination. The second is whenever we are pipetting viscous liquids. And whenever we are working in the flow, we always try to use pipette tips with a filter in it. Regarding other equipment in the lab, here are a few things to keep in mind. So first of all, we have an online reservation system. Not all equipment has to be reserved beforehand, but quite a lot of it does. So please check if you need to reserve the equipment you want to use beforehand. A lot of the equipment has a logbook next to it, whenever it is important to fill it in correctly. Usually we fill in your name, the date, and whatever settings you are using on a machine or whatever you are running on a machine. For certain machines, for certain equipment, you do need training. Also read the manual before using the machine. And we have a protocol database and a YouTube channel with some extra information. So here is a list of the machines for which you need to be trained by a lab technician. First of all, the centrifuges, the confocal microscope, autoclave, speed vac, the ultracentrifuges, pH meters, and the liquid nitrogen tank. Regarding other equipment, if you have any questions before using it, please do ask a lab technician. And a small note, for the master and bachelor students, they are strictly forbidden to use the Sorval, the speed vac, and the autoclave without supervision. The autoclave is meant for the sterilization of materials and or buffers that are able to withstand high temperatures and pressures. Autoclaving gets rid of most living organisms and contaminants, though it is important that it does not remove any DNA or any other molecular contaminants. Keep in mind that one autoclave run takes a bit over an hour, so if you start one at 5 or 6 p.m., you're required to stay a bit later to empty it once it's finished. Do try to empty the autoclave once your run is finished, as anything that has agar or gel-rite in it will solidify if you leave it for a longer time. So we also don't leave anything overnight. Furthermore, be mindful not to overfill your bottles. We only fill bottles up to 80% of the bottle's volume. If you fill it more, you risk the bottle overflowing in the autoclave. Before placing your bottles into the autoclave, be mindful not to close the lid too tightly and to label your bottles with your name, a date, and a content. And use autoclave tape as well. Autoclave tape, an example of this you can see on the bottom picture. It's white tape with yellow lines, and these lines will turn black after a successful autoclavation run. Once your run is done, don't forget to close your bottles before taking them out and before putting them into the oven. Then, regarding centrifuges. First of all, be mindful that for every type of volume you are using, so smaller or larger Falcon tubes or Eppendorf tubes, there usually are different rotors, so use the correct one. Furthermore, it is really important to balance the instrument properly. Whenever you are using Falcon tubes, also take off the caps. Here you see a few diagrams, a few pictures on how to correctly balance a centrifuge. If you have a weird number of Falcon tubes and you're not sure if it is balanced correctly, ask someone else before actually starting your centrifuge. In the product room on the ground floor, you can find a table with 2 balances, which are of course used to weigh whatever product you need to weigh. Be careful that most of the lab products are very expensive and we do not want to waste anything. And it is also forbidden to put any product that you took out of a container back into the container. So whenever you are weighing something, be careful to only take out whatever you need. The balance you can see on the left picture, that's the balance that's on the right on the table. This one is used to weigh very small amounts, but also be careful that you can only put a maximum amount of 40 grams onto this balance. After you're done using the balances, please switch it off. Clean the area around the balances, so the paper on the table. Clean the balances itself. Clean whatever spoons you used to weigh. And should you use the last amount of 70% ethanol in the bottle, refill it. In the end, put all the products you used back at their place. If you did everything correct, the table should look the same as it looks on the top picture. On the bottom picture, you see a few things that are going clearly wrong. The balance is very dirty. There's a dirty spoon next to it. the paper on the table is really dirty. It's not supposed to be like this. Left from the balance, you can see a pack of weighing boats. These usually should be on a shelf, and you just take the one weighing boat you need and leave all the rest over there. Alright, now we're going to go through some best practices, some things to keep in mind when working in the lab. Then a few general things to keep in mind. First of all, shut down all machines after using them. This includes microscopes, flows, centrifuges, balances, PCR machines, and any other power sources. Regarding the PCR machine, don't let them run over the weekend. And if you do leave any samples in the machine for a prolonged time, do so at 10 degrees and take them out as soon as possible. Then refill every container that you empty. So for example, ethanol bottles, you have to fill them yourself with 70% ethanol, and glass bottles for flames with 100% ethanol. Ethanol for these use cases you can find in a Terra Nova, just behind the door. Also refill milk containers and replace waste boxes and containers once they are full. Lastly, whenever you are done using gas, turn off the gas valve, and please don't leave any stuff in or around the sinks. Though this might seem obvious, it is really important to keep the lab as clean as possible, and especially the gel electrophoresis rooms and the weighing rooms. This of course is also true for all the other rooms, common rooms, yes, also the kitchen, the corridors, your personal bench space, and the flows. Also regarding the flows, these ought to be cleaned with 70% ethanol, and all the bottles and Falcon tubes, all other containers that you have inside of the flow should be closed as much as possible. Should you happen to spill something in a flow cabinet, report this immediately to someone of the technical personnel and clean up right away. Also of note, no more Petri dishes with ethanol in the flow next to the Bunsen flame. Regarding the dishes, we have a rotating calendar where every so often it is your turn to do the dishes for an entire week. This calendar can be found in our shared OneDrive folders. Whenever you are working in the lab and you have a piece of reusable glassware that you're done using, before rinsing it and putting it in the plastic baskets, please remove any tape. Any leftover writing can be removed using 100% ethanol, and any glue residue on the bottles can be removed using acetone. So once again, once the bottle is clean and rinsed, you can put it away in the plastic basket, which is then used to carry this glassware to the dishwashing room. Any caps are kept separately in the metal basket for this. You can see the metal basket on the top picture on the right, and a plastic basket for glassware on the bottom right. Regarding glass vials, these should be rinsed as well, but they are kept in a separate bucket completely submerged in water. A good tip to keep them submerged is just to add water before putting in your vials. So as you can see on the pictures, the issue on the top left is the fact that the glass vials aren't completely submerged. And on the bottom left, the caps are submerged in liquid, though they're not supposed to. Also, the tape from the top of the caps should be removed. Whenever it is your turn to do the dishes, here are a few things to keep in mind. First of all, on the left picture, you can see how glass vials should be put into the dishwasher. You have the same metal baskets that are used to store plastic caps before carrying them to the dishwasher room. In these metal baskets, you put all the glass vials upside down. Then the plastic caps, they can be put into the large metal basket, which can directly be put into the dishwasher. If you check the basket for glassware on the right, it has metal spikes on which you can put all the bottles, Erlenmeyers, and so on and so forth. Though be careful, because the left bottom spike is used to disperse water and soap into the actual machine. So this one spike should not be covered by any glassware. Then, for any consumables and chemicals we use in the lab. So for any consumables, there are 3 separate stock rooms. We have one in the museum and 2 in the basement hallways, one of which being across of the confocal or Wormotel room, and the other one is across of the washrooms. For chemical products, each product has its own designated chemical stock number. All of our chemicals and their stock numbers can be found on SharePoint, which is accessible through all general PCs. One important thing of note, chemicals are only stored centrally, so they're for general use. Under no circumstances should any chemicals be stored for personal use, so in your own bench or whatever. If you finish a product or see that something is running out soon, add it to the order spreadsheet, which can be found on OneDrive. You can just use the name with any details, but preferably use our internal stock code if it's a general lab supply. Also, please notify ATP so that we can order these, and whenever you're taking something from our backup or the supply center as well. Finally, we come to waste management, which will be the last part of this presentation. So for non-biohazardous things, there are a few standard waste containers. First of which being just an ordinary gray or black plastic bag, which is used for general waste. A blue plastic bag, we call it PMD. It's used for plastics and small metals, and also drink cartons. There's one exception, so tip boxes from Sarstedt. These are recycled and you can find a plastic box in the products room. Any paper can be put inside, and this is important, inside of a larger paper or cardboard box, which can be found in the corridor. And in the coffee room can be found a basket for biodegradable waste, as well as a basket for glass. At the end of the hallway, there's also a plastic bag for filler chips, and in the entrance hall, there's a large plastic bag for Isimo or styrofoam. Whenever you throw away styrofoam, please be mindful to remove any stickers, extra tape, notes, or whatever. Otherwise, the styrofoam will not be taken away for recycling. This slightly chaotic slide is here for one reason and one reason only. It's to prove the point that it's never as easy as explained on the last slide. There will always be exceptions and weird waste objects. So whenever in doubt, just ask. You, the environment, and your colleagues will be better off. For lab waste, it is a bit more complicated, but in general, whenever you finish a product and it came in a plastic container, you can dispose of this container underneath the entrance table in a bucket. This is especially important for product containers with a barcode. Then there are 2 liquid waste points in the lab. These are fume hoods where you can find spill trays with different bottles on it. One is in the DNA lab and the other one is in the proteomics room. The one in the DNA lab has bio waste as well as chemical waste. The one in the proteomics room is only chemical waste. Chemical waste is where the slightly complicated part comes in, though if you just read all the labels, they should explain themselves. Chemical waste is defined as any liquid or solid substance that can trigger or cause a chemical reaction, and it is split up in 7 different categories. Category 1 through 5 are for liquids, and 6 and 7 are for solids. Regarding the liquids, category 1 is for acidic inorganic waste liquids, 2 for alkaline inorganic waste liquids, 3 for non-halogenated organic waste liquids, and 4 is for halogenated organic waste liquids. 5 is a special category for certain liquids which need their own waste container. Category 6 is for small chemical waste, and 7 is for lab glass. Lab glass has its own large yellow bin, which can be found in the basement hallway. Whenever one of the containers is full, you close it well and put it on the spill tray in the hallway. Then you can get a new container from the basement, put the correct label on it, and put it back in the fume hood. whenever the inevitable moment comes that you're doubting the waste management of a certain chemical, you can look it up through ChioLookit. So log in into your ChioLookit and navigate to HSE and Spaces. Under the HSE category, you can find a button that says Hazardous Substances and Labels, which will open a new menu with a search bar. You can just look up the chemical you're trying to get rid of or dispose of, which will then open a new menu where you can find a button that says Regulations Without Transport. And in this menu, in this drop-down menu, you can also find the correct category of wastes for this chemical. In many of the lab spaces, you can also find a flowchart that helps you to quickly determine the correct category of waste where you can get rid of your chemical. We come to our last category of waste, which is hazardous biological waste, or in Dutch, the abbreviation is RMA. For this, we have, as you can see, yellow-white boxes, which have a few rules we need to adhere to. First of all, these have a 10 kilogram weight limit, so even if they are not full, but they're getting quite heavy, it is time to replace them. Of course, do not overfill them, and it is forbidden to put any liquid waste in them. So whenever you have a Falcon tube with any liquid in it, first get rid of the liquid, and then the contaminated Falcon tube can go into one of these yellow boxes. So it is dedicated to solid bio-waste, for example, Petri dishes with culture medium, empty culture bottles, so on and so forth. Apart from the cardboard yellow and white boxes, we also have these plastic containers. These are used for pasty and liquid biological contaminated waste. And also, as you can see, the plastic pipettes, the larger ones, that were also contaminated with biological waste. For example, from liquid bacterial cultures. Please be mindful that these containers are a tad bit more expensive than the cardboard ones. So in a situation, if you can use a cardboard one, please do so. On the left, you see a few examples of their use. For example, in the gel-rich room, we use these plastic containers to dispose of agarose gel. And you can also see a picture of the way we dispose of the pipettes. Please also remove the wrappers from the pipettes so more of them fit in one container. In the middle, you can see how we dispose of larger volumes of liquid biological waste. We use any container in the lab that is not in use anymore, usually old containers from ethanol. You can just write bio-waste on them, put them on the trays where all the other liquid waste is, and when this container is almost full, close it tightly and also put it in a plastic yellow container, as you can see on the left. Finally, we have needle containers, as you can see on the right. These are smaller yellow plastic boxes with a white lid. And these are used to dispose of small sharp objects, small pieces of glass, needles, scalpels, whatever else. Please be careful when you remove or when you dispose of these things. With needles, don't recap them. This is quite dangerous, so just dispose of it as is, and never fill the small container more than 3/4. Once it is almost full, just close it and also dispose of it in a larger plastic container. And yeah, also please put a new one in its place. If you notice that one of the yellow boxes in your lab is almost full, or is full, close it properly. You can follow the instructions on the boxes themselves on how to close them. Write the number 510 on it, and put it in the hallway next to the DNA lab. Once per week, we carry all these boxes to a designated waste storage area in a different building. Whenever you take away one of the yellow boxes, also replace it with a new one. Once again, be very careful not to overfill any of the waste containers. You might think that it will save you time in the moment, but in the long term, it costs way much more time and effort to sort it out afterwards. Then finally, the next to last slide. We're just going to go through a few of the points mentioned before this and some extra things to keep in mind when handling waste. The first of which is to, whenever you have a container, to keep it free from any contamination on the outside and see that there is no waste trapped between the container and the lid. This is important for other people handling the waste. For example, any of your lab colleagues who might not know where this waste comes from, but also and especially for the KU Leuven personnel that handles the waste after us. They do not know where this waste comes from and what the risks involved are. So it is on us to keep it as clean as possible and as safe as possible for them as well. Then, as I said before, do not overfill your containers. Do not put any liquid waste into the cardboard containers and respect the maximum filling height and weight allowed in containers. One more point to keep in mind is whenever you have hot waste, to let it cool down first before getting rid of it. And whenever you have some glassware which contained any chemicals and you rinse it with water, this small amount of water is also considered chemical waste. Lastly, whenever you have a mixture of biological waste and chemical waste, it is considered as biological waste and should be disposed as biological waste. All right, this last slide concludes our yearly lab safety presentation. First of all, I want to thank you all for sitting through this with me. And I also want to remind you that we don't just watch this to tick off a box because someone said, do we have to watch this? Everything that we talked about, from personal protection equipment to waste management, really is important. And as scientists, I would want to ask from you all to use your head before you do something in the lab. Be responsible, plan ahead, try not to waste any material, and create a safe environment for yourself and for all of your colleagues. Thanks once again. Be responsible and have fun.